Hello everybody, welcome back to the very important course about capacitor panels. Now you are welcome back to the testing broken down capacitors panel for 3-phase 400 volt desalination plant with which draw 100 ampere. Now I'm going to discuss and explain about a very important panel which consists of sum of capacitors for a desalination plant. As you see here in the picture, you can see contactors, you can see circuit breakers, you can see also capacitors, and they are each combined and connected with each other to do the task. And this is the second part of the desalination plant for the panel. As you see here, this is the power analyzer. Here I was going to test by this device, and this device can show for you everything for power, all the kinds of the power consumed by this plant, and can show all the amperes and can show for you everything related to the power analysis. Okay, after we had connected these terminals with the circuit breaker or the fuses box here in the distribution panel, we were testing to discovery or to discovery and to search for the problem or the technical problem for this panel. Okay, go on. This is the screen of the power analyzer. The power analyzer show three phases or the consumed power. There are reactive power and there are true or real power. P1, P2, P3, they are the three phases of the real power. Q1, Q2, Q3, they are three phases of the reactive power. S1, S2, S3, they are the apparent power or the total power of the three phases. Power factor 1, power factor 2, power factor 3, and finally the average power factor for this system at the load or at the factory or at the plant. From the results of the screen of the examination apparatus, the following is shown. 1. Reading total active power of three phases equals reading total active power of the three phases and equal to 61.355 kilowatt. Reading total apparent power equals 67.249 kVA. Reading total reactive power and equal to 27.533 kVAr. Finally, reading average power factor for three phases and equal to 0.9123. It's assumed that the power factor of 0.91 appears on the electronic mind screen, but it showed a value of -1. This is an incorrect number. As you see here at this electronic mind screen for the power factor, this is not a true value. It must be of value of 0.91. It must be shown here. Okay, now let's discover where is the breakdown, or where is the mistake or the error which had been at this plant. So after that, the components of the capacitors plant were examined gradually. So I want you to ask a very important question for this. What do you guess the problem was? Let me answer. The capacitors were checked by measuring the ampere of the capacitors wires and showing that they were working in a cold condition. The input and the output of the wires in contactors for each unit of capacitor were checked and found to be in good condition. Capacitors' fuses were checked and found to be in good condition. Finally, fuses of the contactors were examined and 3 of them were damaged, which caused failure of a portion of the capacitor's power to pass into the load and causing a false reading at the electronic mind. There were some fuses of the contactors were in fault.